Welcome to The Explainer. Today we are going to tackle a concept that's absolutely fundamental to programming, nested statements in Python. This is the stuff that makes the digital world tech.
So, have you ever stopped to think about how your favorite game knows you've unlocked a secret level? Or how an app handles your login? It's not just one decision, it's a whole chain of them, one leading to the next.
And that's exactly where nested statements come in. At its heart, it's just putting one piece of code inside another. The best way to picture it is as combo logic. Seriously, think about a fighting game. You can't pull off that awesome finishing move without landing the first few hits, right? It's the same idea. One thing has to happen before the next can even start.
All right, so let's really dig into this power of combo logic. We're going to break down some of the most common patterns you're going to see absolutely everywhere.
First up, we've got what I call the gatekeeper combo. This is your classic nested if-else statement. It is perfect for handling those layered decisions where you have to clear multiple checks.
Okay, look at this code here. The outer if is our gatekeeper. It's asking one simple question. Is the score 60 or more? If the answer is no, it's game over. You get an F. But if the answer is yes, that gate swings open and then we get to the inner check. The code inside asks, okay, great, but is it also 90 or higher? If it is, boom, S+ rank. If not, you still get a solid A. See how that works? The second question is never even asked unless the first one is passed.
And you see this kind of logic all the time. Think about how K-pop apps rank fan votes, or how your school's website calculates your final grade. It's even used for security, checking not just if you're a user, but if you're an admin with special powers. It's all about clearing one gate before you can even approach the next.
Okay, so that's how we handle decisions inside of decisions. But what if we need to do something over and over again in a structured way? Well, for that, we need to build some different combos using loops.
So let's talk about the grid combo. This is what you get when you nest one for loop inside of another one. And honestly, this is how programmers build pretty much any kind of grid or table you can imagine.
Let's break down how this works. The outer loop, the one with the I, is in charge of the rows. It's going to run for 1, then 2, then 3. Now here's the key part. For each of those runs, the inner loop, the J loop, has to run its entire course. So when I is 1, J will go through 1, 2, and 3. Then, and only then, does I become 2, and the J loop does its whole thing all over again.
And this is the beautiful result. That simple little piece of code creates this perfect multiplication table. You can literally see how the outer loop set up the rows, and the inner loop filled in all the columns for each one. That is clean, powerful stuff.
This pattern is the absolute backbone for stuff like tournament schedules in sports games, seating charts for concerts, row 10, seat 5, and even complex tables in role-playing games, like calculating how much extra damage a fire spell does to an ice monster.
Now let's kick it up a notch. Things get really interesting when we start mixing and matching our if statements with our loops. This is how we can filter through data or make an action happen only when the time is right.
So we're going to look at two key patterns here. First is the filter combo, which is an if statement inside a loop. Then we've got the countdown combo, which is a loop inside an if statement. They might sound almost the same, but trust me, what they do is totally different.
Okay, first up, the filter combo. Here, the for loop is just going through all the numbers one by one from 1 to 10. But inside that loop, the if statement acts like a bouncer. It uses that little %sign, the modulo operator, to check if a number can be divided by 2 with nothing left over. In other words, it's asking, hey, are you an even number? So the loop just keeps on running, but the if statement is filtering, only letting the even numbers get through.
Now check out the difference with the countdown combo. In this case, that for loop doesn't even think about running unless that first condition is met. That start match has to equal yes. So the if statement is the trigger. Once that trigger is pulled, then the loop kicks in and starts the countdown sequence. This is literally how games like Mobile Legends or PUBG work. The match doesn't start until the condition is met, and then the countdown begins.
Okay, we've learned the individual moves, we've practiced the combos. Now it's time to put it all together. Let's face the final boss, building a complete, practical system you'd actually use. And what's more practical than a secure login system? I mean, we use them every single day.
This is the perfect challenge to showcase the combo logic we've been learning, because to make it secure, it has to be nested. The logic here is a super clear, step-by-step process. First, you check the username. Only if that's right do you move to step 2, you check the password. And then, based on that final check, you either get in or you don't. The flow itself is already nested.
And here's the code that makes it all happen. Hey, look at that. It's our old friend the gatekeeper combo. The outer if checks the username first. If it's not admin, the program doesn't even bother asking for a password. It just says username not found. But if it is admin, then we go inside, we ask for the password, and a second nested if statement takes over to check if that's correct. That layering is what makes the system both smart and secure.
Getting this concept down isn't just learning a new trick. It's a massive power-up in your journey as a developer. Let's do a quick recap of the new skills you've just unlocked.
So here are the core patterns we've covered. We have the nested if-else for those layered checks like grades. We've got the for inside a for building out grids. And then the two powerful hybrids, the if inside a for, our filter combo for picking out specific items, and the for inside an if, our countdown combo for triggering a sequence. Knowing when to use each of these is a real game changer.
Mastering this type of logic is absolutely essential. And when you do, you basically gain 5 new coding superpowers.
And here they are. You now have the fundamental logic to build secure logins, to create systems of rewards or penalties in a game, to filter data like in a voting app, to calculate complex results, and to design all sorts of cool game mechanics. This isn't just abstract stuff. This is the real logic that makes our favorite digital tools work.
So at the end of the day, we've seen how these simple nested building blocks, this combo logic, is what constructs the incredibly complex digital worlds we interact with. So the only question left for you is, now that you know the secret, what are you going to build with it?